Assalamualaikum and good evening, everyone. Ladies and gentlemen, respected lecturers and esteemed participants. Welcome to the Mathematics Unit's collaborative teaching session titled From Multiplying Matrices to Encoding Secrets. I'm happy to be the moderator for today's session. My name is Nur Inshira Nadra, and I'll be hosting our discussions and activities. Let us start with Dua recitation to seek blessings and guidance for our assembly.
Kita mulakan majlis dengan bacaan Ummul Kitab Al-Fatihah. A'udzu billahi minasyaitonir rajim. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala sayyidina Muhammad wa ala alihi wa ashabihi ajma'in. Ya muzila rahmat wa ya fatihal barakat. Kami rafakkan kesyukuran penuh harapan kerana pada hari ini kami masih diberi peluang untuk meneruskan pencarian rezeki yang melimpah ruah di atas muka bumimu yang luas ini. Engkau berkatilah dan rahmatilah perjalanan syarahan kolaboratif ini pada hari ini. Sesungguhnya engkau maha mengetahui bahawa kami di sini ingin menyebut ilmu-Mu bagi mengembangkan ilmu pengetahuan kami sebagai hamba-Mu yang engkau redai. Justru kurniakanlah kepada kami limpahan ilmu-Mu. Sinarilah hati kami dengan hidayah-Mu agar kami mudah menerima dan menghayatinya dalam kehidupan kami. Ya Allah, Ya Mudabbir al-Amri, pada saat dan detik ini juga kami pohonkan ihsan dan pimpinan-Mu agar engkau anugerahkan kami kesabaran yang utuh, ketabahan yang jitu, kerjasama yang erat, semangat permuafakatan yang padu dan semangat juang yang tidak mengenal erti putus asa dalam memikul tanggungjawab sebagai pencipta ilmu, yang berusaha menyambung tenaga, idea dan kepakaran demi meningkatkan kualiti pendidikan negara. Engkau bantulah kami dalam merealisasikan objektif syarahan ini, iaitu antaranya menambahkan ilmu pengetahuan para pelajar dan meningkatkan inovasi melalui pengajaran serta pembelajaran. Allahumma ya Rahman ya Rahim, hanya padamu kami memohon. Kurniakanlah kepada kami kejayaan dan kecemerlangan. Jadikanlah kami golongan hamba-Mu yang mendapat kemuliaan dunia dan akhirat. Panjangkanlah usia kami dengan amalan taat kepada-Mu dan suka berbakti kepada agama-Mu serta berjasa kepada bangsa dan negara. Allahumma ja'al jam'an hadza jam'an marhuma wa tafarraqna min ba'dihi tafarruqan ma'suma. Allahumma ighfir lana dhunubana wa li ikhwanina allazina sabaquna bil iman wa la taj'al fi qulubina ghillan lil ladzina amanu rabbana innaka ra'ufur rahim. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. صلى الله على سيدنا محمد وعلى آله وصحبه وسلم. سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين.
Amin amin ya rabbal alamin. Alhamdulillah. Thank you Muhammad Hazmil Amri for that beautiful recitation. Now, let us extend a warm welcome to our program representative, Dr. Suzila Muhammad Kasim, who will share some remark with us.
Assalamualaikum and salam sejahtera. Thank you to our moderator, Ms. Nur Inshirah Nadra, for her role in guiding today's session. All staff in Center of Foundation Studies at Dengkil, all academicians, all students and audience. I would like to begin by extending a warm welcome to our distinguished speaker, Dr. Wan Nur Aklili, or we can call her Dr. Lily, who has made significant impact or contribution to our understanding of matrices and their applications. Today, Dr. Lily will guide us through the fascinating world of matrices, exploring their fundamental concept and practical uses related to data protection. Thank you once again for being here, and let's make this a truly impactful event. Thank you. Back to the moderator.
What an amazing speech. Thank you so much, Dr. Suzila, for your informative thoughts. Ladies and gentlemen, I have one question for all of you. Have you considered the practical uses of mathematics in your life or future career? Or have you pondered how classroom matrices apply to real world situations? Well, you're not alone. Today, we are honored to host an esteemed speaker who represents the blending of academic excellence and practical applications. Please join me in extending a warm welcome to our respected speaker, Dr. Wan Nur Aklili Wan Muhammad Rizai. Dr. Wanor Akili Wan Muhammad Ruzai, or more comfortable to be called as Dr. Lily, whose expertise in mathematical cryptography will certainly enhance our learning today. We are honored to have you with us, Dr. Lily. Allow me to provide you with a brief overview of Dr. Lily's amazing background. Dr. Lily is a lecturer at the School of Distance Education at University Science Malaysia. She received her doctorate in mathematical cryptography from the Institute of Mathematical Research at University Putra Malaysia. She is a member of Malaysian Society of Cryptology Research (MSCR) and the Malaysian Mathematical Sciences Society (Bersama). Her research primarily focuses on mathematical cryptography, algebraic cryptanalysis, post-quantum cryptography, and computational number theory. Her work, which titled Cryptography, the Mathematical Foundation of Digital Security, epitomizes the fusion of mathematics and security to safeguard our digital world. With her extensive background, Dr. Lily represents today's theme, from multiplying matrices to encoding secrets, by demonstrating how theoretical knowledge can be applied to practical problems with ease. Ladies and gentlemen, this session is interactive and open to everyone. So please participate, ask questions, and share your opinions and experiences during the Q&A session. You are all here to learn from one another and improve your understanding of matrix concept. You may use the chat tool at any time throughout the session. As we go through the Q&A, I'll monitor the conversation to ensure that Dr. Lily answers your question. Without further ado, let's begin a discussion from multiplying matrices to encoding secret. Dr. Lily, now the floor is yours.
Okay, Assalamualaikum and good afternoon to everyone. My special thanks to Inshira for moderating this session. Okay, you all can hear me, right? Okay. Okay, first of all, thank you for being here today, for taking your time to attend this session. Before we proceed with the sharing session, I would like to take a moment to express my sincere gratitude, especially for Dr. Suzila and the Mathematics Unit of Pusat Asasi UiTM Dengkil for organizing this session and giving me the opportunity to speak to you all. Okay, honestly, I'm excited to meet you all, even virtually, and share about how mathematics, particularly the matrices, connect to the application in the cryptography world. Okay, I will start sharing my screen. Okay. Okay, can you all see my screen now?
Yes, it's visible.
Okay, it is visible. Okay, so I will proceed. Okay, so for today's session, I will share on the topics from multiplying matrices to encoding secrets. Okay, so some of you might be unfamiliar with the word cryptography. So cryptography, okay, first of all, I would like to share on cryptography. So cryptography is the art and science of encoding information. Okay, so generally we can say that cryptography is a method of protecting information and communications using codes. So that only those who are intended to read our information can receive it. Okay, so I will talk on the application of the matrices to encode secrets. Specifically, I will focus on the Hill cipher. Okay, so here is the outline for this session. I will introduce why cryptography matters, and then I will share on part 1 will review on the matrices and the system of linear equations, and then we will go through part 2, which is the application on Hill cipher, and then I will conclude the session and the Q&A session. Okay, so I hope I've been told that most of you are already done with this part 1 topic, which is on the matrices and system of linear equations. So I will just briefly go through this part. I will focus only on the part that is significantly for the part 2 later. Okay, I hope that by the end of this session, you all will see the practical usage of these matrices in order for protecting the sensitive data. Okay, so before we jump into the maths stuff, okay, let's us talk on this cryptography. So why this cryptography matters? Okay, so since we are in today's world, we heavily rely on the internet, and also we many of our daily mission critical activities, tasks and jobs also require us to use the internet and also all the encrypted digital platform. Okay, so as we all use in our daily life, okay, we use the credit and debit card to buy groceries, right? Also, we use our smartphone to connect to wireless network, and also for text messaging, and also for the apps to chat, and in order for us to connect to our family and friends that are outside our area. Okay, so from the ordinary pakcik or makcik to the business organization or the government agencies, today's world are all relies on the power of encryption. Without we realize it, we actually relies on the power of encryption to make our data confidential and secure as much as possible. And also with the advent of big data and also the Internet of Things, there is a need for us for the encryption. So this encryption mechanism will only grow exponentially in years to come. Okay, so historically, this cryptography has been around for thousands of years, dating back since the ancient time, during the Egyptian time, during the Greeks, and also Romans. But it has evolved dramatically, especially now in this digital age. In today's, we okay. For example, the Egyptian, they use the hieroglyph to hide the meaning of an inscription. Okay, so this is the figure for the hieroglyph. The example how the Egyptian in during the ancient time used to hide the meaning of message. Okay, here is another example of the usage of encryption mechanism, which is by using a cipher during the Roman Empire and also the Spartans. They wrote sensitive message on strips of leather wrapped around stick. So this one we call that as a cipher. As you can see, this is the picture of the cipher. So the uh, usually the military will use this to communicate during that time. Okay, that one is during before the 1970s. The encryption relies on the method that we call the symmetric key. But after 1970s, okay, the encryption changed into what we call today the public key cryptography after two gentlemen, namely Diffie and Hellman. Okay, they practically propose the usage of public and private key, and they successfully solved one of the major roadblocks in cryptography, which is how to securely distribute the encryption key to those who need it. So among the application of this asymmetric crypto system or the public key crypto system is the one that we use today, such as RSA and also the ECC, electric curve cryptography. Okay, this is just some brief idea on what is cryptography. Okay, so basically we use the encryption as a way for us to secure the communication. Okay, but today this encryption mechanism does not simply mean you hide the message on stick. Okay, so it is now defined as the conversion of intelligible data, such as if you have numbers, text, sounds, and also image, into another form. This another form, which is we call as the cipher tag. So if we saw the word cipher tag, it means that the message has been encrypted. Only those who are intended for that message will have the right to recover the message. Okay, as you can see in this figure, okay, let's say you want to communicate between your friend, you and your friend. Okay, let's say we have Alice and Bob. Alice wants to send the message to Bob. So Alice needs to make sure that the message safely delivered to Bob without the interruption by if. If here refer to the adversary or the attacker or the third party. So if will always be in the insecure channel. So the internet that we use today is the insecure channel. So to make sure that the information that we send through the insecure channel, which is the internet, is encrypted. So we need to use this method. Okay, so Alice and Bob both will have the public and also their respective private keys. Okay, and then Alice will transform the plain text. Plain text here refer to the original message. Okay, transform to cipher text. Okay, using the method encryption. So Alice will encrypt the message using the public key of Bob. Okay, and then public key meaning that everyone can see your public key in the public domain. Okay, so Alice will use Bob's public key to encrypt the plain text or the original message, and then it will become the cipher text. Okay, cipher text is the tag yang rahsia tu, and will send over the insecure channel to Bob. So uh, if only can read the not the message, not the real message. And then after Bob receives the cipher tag, Bob will perform the decryption process in order for Bob to read what Alice has sent to him. So Bob will decrypt using his own private key. Okay, and then Bob can recover the message. So this is basically the idea on how the public key works, the public key cryptography works. This is also the idea on how if we send the sensitive information online, if you send the email, this is the mechanism that works behind that. Okay, so we will continue with this part 1 on the matrices and system of linear equation. Okay, so basically, I just want to recall back your knowledge on these matrices. Okay, so as the definition, a matrix is defined as an ordered rectangular array of numbers. So these numbers in that is called the entries or the elements of the matrix. And we usually denote the matrix with the capital letter, such as this A and B and etc. Okay, some of the example of the matrix is given by this one. Okay, let's say you have this matrix A. Okay, this matrix A is a 4 by 1 matrix, right? And this one is 3 by 2 matrix. So the order for this, you just count the row multiply with the column. And this one is matrix 1 by 3. Okay, if you have the square matrix meaning that you have n by n matrix. Okay, let's say you have this 2 by 2 matrix. Let's say you have D here. You will have something like this, 4, 5, and so on. Okay, so the order of matrix is important when we start doing the operations, such as if you add between the matrices, you multiply, and this will be crucial in the encryption later. Okay, for the metric operations, I will just focus on these two, metric addition and metric multiplication, as these two operations will be used later in the encryption and decryption process for the Hill cipher. Okay, let's say if you want to add between the two matrices, okay, you have the first matrix here. Okay, if you just add between the elements of these two matrices, and you need to make sure that the size or the order of the two matrices must be the same. So you just add 1 plus 5, you have 6. 2 plus 6, you have 8 here. And then 3 plus 7, 10. Here you got 12. This is quite very straightforward. So just this the answer. If you have 2 by 2 matrix, then if you add between 2 by 2 matrix, then the output also will be the 2 by 2 matrix. Okay, next for the matrix multiplication, if you multiply between these two matrices, okay, you need to Okay, you need to take the dot product between the first row of the first matrix and the first column from the second matrix. So you will have here, okay, since here 2 by 2 matrix, here 2 by 2 matrix, so the output also will be 2 by 2 matrix. The product of these two will be 2 by 2. So you will have here 1 you multiply with 2, and 1 you multiply with 5, sorry, plus 2 you multiply with 7. Okay, next element you will have 1 you multiply with this one, 1 multiply 6 plus 2 multiply 8. And then for this second row, you will perform 3 you multiply 5 plus 4 you multiply 7. Okay, you repeat the same process for the second column here. You 3 multiply 6 plus 4 multiply 8. So you will have here 19, 7 plus 5. You will have here 19. This part you will have 22, here 43 and 50. So this is the answer for this multiplication. Okay, next on the system of linear equations. So another key use of matrices is we can solve the system of linear equation. Okay, suppose here we have these two equations. The first one, 2x plus 1y, okay, equal to 5, and the next equation, 3x plus 4y. Okay, so we can represent this system of linear equations. Okay, we call linear because the highest power is 1 kan. Okay, so we can represent these two linear equations into metric form. So how do you transform this? Okay, so we can write from here, we can write as 2, 3. You take out the coefficient of each variable here, 2 and then 3, and then for this part 1 and 4. And then for the second metric, you will write x and then y, because here we have x and y. Okay, and then you equal to this element here, 5, 6. Okay, so now you can use the method that this one is like the metric multiplication kan. So the metric here, actually we call this as the coefficient metric, and this one is the constant metric. Okay, so in order for us to solve for x and y, okay, we can multiply this. Actually, there are many ways to solve this. Okay, one of the way to solve for this is you multiply between these two. Okay, and then after you perform the step, you will have the answer. X will have, your x will be, okay, this one you will transform, okay, x, y. You need to find the inverse, right? If you use the metric, you need to find the inverse for this Okay, the final answer will be x will be 14 over 5 and the y will be negative 3 over 5. Okay, if you have any question, you can ask. Okay, now that we have covered on the metric addition, metric multiplication, and also some of the system of linear equation here. Okay, I will go into part 2, which is on the application of the Hill ciphers. Hill cipher. Okay, so this Hill cipher is actually developed back that in 1926 by its inventor Lester S. Hill, and this Hill cipher is a type of classical symmetric key cryptographic algorithm which use a metric-based approach to encrypt and decrypt the message. Okay, so this cipher is known for its strong mathematical foundation and its ability to handle long message. And this Hill cipher previously been used in various applications, including the military communications, in the banking, and also the computer security. This is due to disadvantages of this Hill cipher. The first one, Hill cipher, is scalability. It means that this Hill cipher can handle messages of arbitrary line by dividing them into blocks of fixed size. Okay, and then the other advantage of using this Hill cipher is on its cryptographic strength, meaning that this cipher, it use the application of the modular arithmetic and also the metric multiplication and the metric inverses that make the Hill cipher more resistant to certain types of cryptanalysis. Okay, and the next advantage of using the Hill cipher is on its flexibility. So this cipher can be implemented using different block size and also key matrices. So it will provide flexibility in the encryption process for the user of that system. Okay, as you can see in this figure is the Hill cipher machine in the uh, patent document for this Hill cipher. And this picture is the developer for this Hill cipher. And this Hill cipher use the metric multiplication. Okay, if you extract the information from the encryption process or the decryption process for this Hill cipher, it will look like this metric form. You will have n by n metric and you multiply with some vector and you will have another vector as the output. Okay, so one of this Hill cipher will have two process. The first one is encryption. So in the encryption process, okay, in order to encrypt a message, okay, we need to perform this operation, meaning that we will encrypt and output the cipher type C, which equal to you multiply between the K here refer to the key metric, and P is the plain type in the vector form. And you will perform in mode 26. Mode 26 because we have a number, we have from alphabetic A until Z. Okay, so multiplying these two terms produce the encrypted ciphertext also in the vector form. And the key, K here is represented in the form of metric. It must be n by n metric. For the key in Hill cipher, it must be the square metric. Okay, square metric. The key must be, you need to remember the key for the Hill cipher must be in square metric. Square metric meaning that n by n. And we need to make sure that the key metric must be, the determinant of this key metric must be non-zero. Okay, so if you have the determinant for 2 by 2 metric, let's say you have this metric A, B, C, D. So the determinant of this metric will be, you will multiply between A, you multiply D, minus B, you multiply C. Okay, and each letter, if you have three, there is formula on how to identify the determinant for the 3 by 3 metric. Okay, and then for the each letter is represented by the number 0 until 25 because our calculation are based on mode 26. Okay, another mechanism for the Hill cipher is the decryption process. Okay, so in order for the receiver to decrypt or read back the message, so he or she needs to perform this operation in order to get back the plain text or the original message. We need to multiply between, okay, the first step is calculate the multiplicative inverse for the determinant or for the K, the K or the key metric. And then in step 2, you need to multiply it with the adjoint metric. Okay, and then lastly, you multiply the inverse key metric with the ciphertext metric to obtain the plain text. Okay, so basically in this step 1 and step 2, we are solving for this part. We want to find what is the inverse for the key metric. Okay, after you have the value for the K inverse, you will multiply with the ciphertext under this mode 26 operation. Okay, I will show you the example on how we can encrypt and decrypt using the Hill cipher. Okay, so first of all, we need to have this table first. This table that maps from A to Z, and each letter here, A will maps to 0, B will map to 1, C to 2, and so on, as letter Z will map to 25. The reason of this mapping or these numbers is because we use the mode 26 because there are 26 numbers of this. Okay, example, let's say we use the key HILL, HILL. Okay, and the plain type here, we choose, let's say we want to send the word exam, EXAM. Okay, sekejap, right here. This one, mode 26. Okay, so first thing first, to encrypt. Okay, in this example, the question asks us to encrypt the word exam using this key, HILL. Okay, so first thing first, we will transform the given key and the plain text into the metric form. Okay, so this actually this is how the military communicate back in the years. Okay, let's see. Okay, first you need to transform hill. I have a problem with. Okay. Okay, so you have the key metric or K, okay, which you will transform this word HILL into metric form. So you will write like this. You will have 2 by 2 metric since you have 4 words, since you have 4 letters here. So HILL. Okay, the next one, the plain text. Okay, for the plain text here, or the P, okay, you will transform exam EX. Okay, you will transform like this, EXAM. Okay. Okay, for the key metric here, since you transform into 2 by 2 metric, okay, recall back, for the key, we need to have the square metric. So in this case, we have 2 by 2. That's why you write the metric for the K in this form. Okay, after you put the letters inside the metric, then you transform this H into this one. H meaning that you will have 7 here. I, you will have 8. L reflect the number 11. Okay, for the plain text, you need to separate the words here. Separate the words here. Since here you have 2 by 2 metric, then here you will have the 2 by 1. 2 by 1. So that's why here you will have this EX, the first 2, and then AM. Okay, so after you put it into the metric form, then you translate E becomes 4, and then X becomes 23. X jadi 23. Okay, and then for the A here will be 0. And M here will be 12. Okay. Okay, first step, you just convert all into the metric form. And then the next step, you just substitute into the formula. Formula step 1. This one is step 1. And then step 2. Okay, you substitute into the formula C equal to P, you multiply with K mod 26. Okay, so I will write on the next page. Okay, since okay, you can together write with me. You can together try and multiply all this. You have 7, 11, 8, and 11. And for the plain type, you have 4, 23, 0, 12. Okay, so for the C, we know that the formula is mod 26. Okay, so for the first part, we will multiply between these two matrices. So you will 7, 8, 11, 11. Okay, for the first C, you will have this. You multiply with 4, 23. Okay, you solve this two matrices by multiplication. You will have here. You will take this one. You will you take this and you multiply with this one. So you will have here 7 multiply 4 plus 8 multiply 23. Okay, and then you will have the next row. You take this name. You take this row. You multiply with this 11 multiply 4 plus 11 multiply 23. So the output for this C1 actually equal to 212297. Okay, this is not final yet. You need to mod 26. Okay, so you just take 212, you mod 26, you will have. And then if you for this one 297 mod 26, you will have 11. Okay, so this actually reflect for okay, actually this one reflecting the number the letter E and L. You refer back to the to this table. If you have 4 meaning that you have the letter E. 4 reflect the letter E. And then 11 reflect to the letter L. Okay, you are done with the first part for the cipher tag. And then the next part, okay, I just wrote this notation. Actually, up to you. You will have 7, 8, 11, 11. You multiply with the next plain text. Okay, so you will solve this. 7 multiply with 0 plus 8 multiply with 12. And then 11 multiply 0 plus 11 multiply 12. So here you will have 96, right? 96 for the first row. And then the second row you will have 1, 3, 2. Mod 26. So the output here will be 18, 2. Which actually reflecting the number SC. So we can conclude that the cipher tag that will be sent to the receiver is equal to EL, this one EL and SC. So no one will understand that this word actually the word for exam, except for the receiver. After the receiver perform the decrypting process. Okay, so if intercept the system, if only can see this word. Okay, next on how to decrypt back from this cipher tag. If you receive this cipher tag, how you will recover back the plain tag. Okay, so we actually will use these 3 steps in order for us to get what is P. Okay, so for the Hill cipher decryption, okay, so first thing first, as mentioned in the first step, you need to calculate the multiplicative inverse for the determinant. Okay, so you need to calculate the multiplicative inverse for the determinant. Okay, since you have 2 by 2 matrix, then it is easy. So the determinant for that just equal to AD minus BC. Since you have the key matrix equal to Hill, that one HILL, which equal to 7, 8, 11, 11. Okay, so the determinant for this, the determinant for 7, 8, 11, 11 is equal to 7 multiply 11 minus 8 multiply 11, which equal to negative 11. Okay, this negative 11, you always need to play with the mode 26, which actually, if you have negative numbers, or if your output negative numbers, or the number that is greater than 26, then you need to mode 26. So you will have here 15. So the determinant D equal to 15. Okay, next step, after you find the determinant, you need to calculate the multiplicative. You need to find the inverse. Okay, find the determinant and then you need to find the inverse lah. Okay, this one is for the 1.1, step 1.1. And then step 1.2, you need to find the multiplicative inverse of determinant of the matrix. So you need to find this 15. So the determinant, you need to find what is the D inverse here, congruent to 1 mod 26. Okay, so we are actually finding the the inverse here. So here you have 15, the inverse congruent to 1, mod 26. So the D inverse is actually equal to, you need to find the 15 inverse mod 26. Okay, okay, which equal, if you since I just use the calculator, because this one will take time if I show you step by step on how to find the inverse. Actually, if you use the scientific calculator, you can find this one. So the D inverse here will equal to 7 mod 26. Okay, okay, next step, in step 2, you need to,
Dr. Lee,
yeah,
um, if I may interrupt, there's one question from your viewer
okay.
asking how to use mode 26 in calculator.
Okay. Alright. If you use the calculator, okay, thank you, Inshira, for the question. If you want to calculate using the calculator, if let's say if you have the negative 11 here, okay, you just plus with 26. This is the shortest way to calculate. If not, you need to divide. You need to do the division method. Okay, you just negative 11, you plus with 26. The first positive number is the answer. Actually equal to 15, right? Okay, if you have, let's say this 212 mod 26. Okay, so the quickest way that you can use using the calculator is you just take this 212, you just minus with 26. The first number that is below 26 is the answer. 212, you minus with 26 until you get the first number that is less than 26. Actually, this mode is, the concept is like you need to find the remainder if you divide between these two numbers. Okay, is it clear? If you have 212 here, you can just 212 minus 26 minus 26 minus 26 until you get the first number that is less than 26. Is it okay? Am I answering your question? If that one, if you use the calculator lah.
Yes, Dr. Lee, thank you so much. You may
Okay,
continue your lecture.
alright. Okay, so in the next step, for the decryption process. So for the next step, you need to find the, multiply it with adjoint matrix. With adjoint matrix. Okay, so the adjoint, for if you have this 2 by 2 A, B, C, D, is the formula is given by this, right? D negative B negative C A. Okay, so if you have this value, if you have the adjoint for 7, 8, 11, 11, which equal to, okay, sorry, it here refer to the key metric. Key metric. So you need to multiply the key metric with the adjoint metric. And, oh yeah. So you will have here 11 kat sini, 11 juga. 7 sorry. Here 7. Negative 8. Negative 11.
Doctor,
Yeah?
I'm pretty sure that most of your students right now are really interested to know.
Mm.
So there's also another question is that
Mm.
how does the D inverse is equal to 7? How do you calculate by D inverse equal to 15 to the power of negative 1
Okay, okay.
being D inverse to equal to 7?
Alright. Set, Okay, for this one, for to make it easy for us, okay, we can make the table for this. Okay, the determinants, multiplicative, inverse modulo 26. Okay, if you have the determinant equal to, okay, this one for the determinant, and then this one for the inverse. Inverse mod 26. Okay, so you take the first number 1, 3, 5, 7, 9, 11, 15, 21, 23, and then 25. Okay. Okay, sorry. Okay, so the output for this inverse mod 26 here will be 1, 9, 21 here, 15, 3, 19, 7, 23, 11, 5, 7, 2, 25. Actually, this one kan, for the output here, actually I just calculate using the software that I use. If we need to compute by hand, we need to use the Bezos lemma. I think that one will be out of the scope for you to, we need to apply the Bezos lemma. But if you use the software like Maple or MATLAB, you can just directly compute 15 inverse mod 26 will have this answer. Okay. Is it okay? So if you can see from this table, this 15 for this inverse actually is 7.
All right.
Okay.
Thank you so much, Doctor. You may continue.
Alright, we continue with step 2 here, which we multiply the key metric with adjoint metric. So the adjoint for this metric is equal to this one. Okay, but you need to remember, since you have negative here, you need to mod with 26. 11. 11, 11, but this negative 8 mod 26, you will have here negative 8 plus 26, you will have 18. And then negative 11 plus 26, you will have 15. Okay, 7, just the same. If that number within the range 0 to 25, if the number is between 0 to 25, then you just use the same number. If the numbers are negative or greater than negative, greater than 25, 26, 26 and above, then you need to minus with 26. If 26, it is actually equivalent to 0 mod 26. Okay, after you calculate the adjoint metric, the next step is you need to multiply D inverse with adjoint metric. Okay, we almost there, almost get the step 3. Okay, and then 2.2, you multiply D inverse with adjoint metric. Okay, so your D inverse that you have just now equal to 7, right? So you multiply with the adjoint that you have, 15, 18, 7, which equal to 77, 165 here, 7 multiply 18, you got 126 here, 49. And then you mod 26. Okay, mod 26, each of the elements inside this matrix, you will have 25, 1, 22, 23. Okay, you just subtract with 26. 77 minus 26 and then minus 26 until you get this, the first positive number, 25. The first positive number that is lesser than 26. Okay, so you have now, okay, K. If our K just now equal to 7, 8, 11, 11. Okay, then our K inverse equal to, the inverse for this will be equal to this, the answer lah, this one, 25, 22, 1, 23. So what we are computing just now is to find the multiplicative inverse for the key metric. Okay, once we already have the K inverse, we can proceed with step 3, which we just substitute into the formula. Multiply the inverse key metric with the cipher type metric to obtain the plain type. So P is equal to C multiply with K inverse. So in this case, you will need to multiply between the CELSC for okay. So now we will have 25, 22, 1, 23. You multiply with 4, 11. Okay. The cipher type that you have just now, C equal to 4, 11, 18, 2. So you solve for the first one, 4, 11. Okay, which you will have here 3, 4, 2, 2, 5, 7. Which this one you reduce with mod 26, you will have now 423. Okay, this 423, you go back to the table that you have just now. 4 reflect to the number E, to the letter E. 23 reflect to the letter X. Okay, then for the second part, this one, so you will have 25, 1, 22, 23, 18, 2, which equal to, after you solving this, you will have 494 and 64, mod 26.
Madam, if
Yeah,
I may interrupt you again, is it
okay.
K inverse multiplied by C first, or is it the other way around?
Yeah, you are right. Actually, the order matter, right? So,
Yes.
here is, there is salah sikit kat sini. So you need to write K inverse, you multiply with, you need to multiply the multiplicative key metric with the cipher type. So the formula should be C inverse multiply with K. C, yalah, C multiply, K inverse. K inverse, you multiply with C. Okay, so for this part, you will have 0, 12. 0 actually reflecting the letter A. 12 actually M. So you combine these two plain type, you will have ELSC. You transform it back into XM. Okay, so uh, this is the procedure on how you will get back the plain text message if you use the here cipher. This is just the example if you have 2 by 2 metric. If you have 3 by 3 metric, then the solution will get complex, will be more complex with the increased number of dimension of your metric. So this is how the the people before us use this cipher to hide the important information in the military. Okay, so I have a task for you now. Okay, can you uh, answer, attempt to answer this question? Okay, you attempt to answer this by you use the Hill cipher to encrypt the following plain type with the following key. You have key UITM and your plain type di hatiku. Okay, you try to transform this using Hill cipher. You try to transform into the cipher type. Okay, I will give you. Okay, since we still have time, I will give you 5 minutes. Can? Okay, the fastest and the most accurate answer will get the special prize from me. Okay, you try to use the procedure here. The procedure encryption. Encryption just simple. You just need to transform. You just need to transform the given key and also the given plain type into metric form, and then you just use this. You just use this one, this formula to solve or to find the cipher type. Okay, can you try? Since this one is also 2 by 2 metric. Simple. Okay, don't share with your friends. You just upload your answer in this Google form link. You can scan this and you snap your answer and you upload in the form. Okay, I will also share the link to the Google form in the chat box. Anyone already answered the question? Dr. Suzila also can answer if you want.
Of mode 26.
Doctor, can you please
Yeah.
override the slide of mode 26?
Okay, can. So I will share back. Hmm. Okay, this one. First, you need to transform the word UITM. The word UITM. Your key now is your key K equal to UITM, which U reflect 20, I T here 19, M is 12. Okay, and then the plain type di hatiku. So you will have several plain type matrix. Okay, so you need to remember lah. If you have 2 by 2 matrix, then for the plain type matrix, you need to, since you have the di hatiku. So you can do what? Okay, no one has been submitting. Are you okay, Ishira? You want to attempt answering? So for this one, you will do like this. T.
Hello, doctor.
Yeah.
I think I got the answer.
Okay. Will you attempt? Tapi
Yeah.
you submit first. You
Okay,
just
submit.
upload. You upload and then you share with me the answer.
Okay.
Upload.
Okay. So far, no one submit the answer. You can access that form, right? Okay, you have another 4 minutes. Okay, any question from you?
Yeah. Doctor, I have submitted
Okay,
the answer. Yeah.
alright, I will check now. Okay, there are 3 people already submit your answer.
Doctor, can you try to
Dia tak boleh bagi ke?
Okay.
go back to the slide where the QR is?
Oh, okay, yeah. Sorry. Okay, this one. Right. Okay, so seems like we already have 2 winners here. So the correct answer, okay, I will just tell the correct answer since you already got it right. Okay, the right answer should be UX. Okay, the answer, okay, I will just write lah. Okay, so the cipher type for the plain type di hatiku with the key UITM is the cipher type UXKDCPWO. WO. Actually, okay, the first person who submit, ada salah sikit. Oh, tapi ada the next person already got it right. Okay, so I will contact you for the prize giving. Okay, thank you everyone for attempting to answer this. Okay, actually, you can just do this for fun if you want to send some message to maybe some of your friends in a smart way. Okay, so as conclusion for today's session, okay, we have explored on how these matrices are used in the system of linear equations and how this same principle apply to cryptography through the Hill cipher. So you can see, right, how the Hill cipher adopt the use of metric multiplication, the inverse of metric, and also the modular arithmetic in the encryption and decryption process. So with that operation, you actually can hide the message. So by multiplying these matrices, we can encode and decode the messages, showing how a concept from the algebra can have practical applications in securing information. So this Hill cipher is a great example of how the mathematical concepts can be used in the real world applications. Although this cipher no longer being used in the modern encryption system, but we can see how the people back then uh, be creative in using the concept, the theory that we learn, such as these matrices to hide the confidential information. Okay, I think that's all from me. If you have any question, you can ask. Okay, before that, okay, some of you asked how the question just now, how from this one, the multiplicative inverse, how this inverse 15 mod 26, we got 7. Actually, this one, since I said just now, saya cepat sebab saya guna apps kan. But if you want to do it manually, you want to calculate it manually, you can try to Google the Euclidean algorithm. Actually, we can compute it. Euclidean algorithm. How to find the inverse of 15 mod 26, which is actually based on this lemma. Okay, but if you Google, actually there is a calculator to, you just input the value for 15 and 26 and you will have this 7. Okay, so any question from you? Okay, you can also reach me at this email later. Okay, you can also submit lagi the answer that you write, that you attempt just now. I can check for you, and I will give feedback since you provide me with your contact information, right? Okay,
Great.
and
Thank you so much, Dr. Lily, for your very insightful presentation. So now we are open for questions and comments. If the viewers or the students have any questions or any comments, please put it in the chat box and I will read it out for you. So
mm,
far, we have one question, which is
mm.
how does the block size affect the security and complexity of the huge cipher?
Okay, so for this specific Hill cipher, actually, if you have a greater size or greater dimension for the metric, then it will be more secure because the complexity for you to compute to perform the encryption and the decryption process will also increase with the increase n, as I think I mentioned here. So if you increase the number of n, then the cipher will be more secure. Okay, I hope I answer your question.
Yeah, thank you, Dr. Lily. That definitely answers the question just now. Another question is that what happens if the key matrix is not invertible?
Okay, if the key matrix is not invertible, then you cannot find the the decryption process will fail. You cannot recover the message back because the inverse does not exist, right? So you cannot proceed. That is one of the limitation for the Hill cipher. We need to choose the K, the key, which is we need to make sure that the selected key is invertible, or else the decryption process will fail, meaning that the receiver of your message cannot read what you cannot decode back or decrypt back the plain text. Okay, so first thing first, we need to ensure our K is the invertible matrix. Okay, so there is a way, right, to check whether the matrix is invertible or not. You need to check for the determinant, kan? The AD minus BC cannot less than 0, right? Okay, so I hope I answer your question. You need to make sure your K is invertible matrix.
All right, Dr. Lily. Just now you said that there will be limitation, which means that if the matrices is not invertible, then you
Hmm.
cannot decode the whole that
Yeah.
tens infinities, right?
Uh-uh.
So, if is there any like modern way of Hill cipher that can solve the problem,
Hill cipher.
or is there
Yeah,
any
yeah.
advanced
Yeah,
technology for that?
yes. I'm sure there is a way. Okay, there is a way to ensure that. Okay, we can. I think if we want to adopt this Hill cipher into this apa modern way, I think we can develop the selection process for the K. For the K to be, we need to choose the right K. We need to choose the right K so that the chosen K is invertible. But theoretically, if we need to make sure K is invertible, I'm not sure lah kalau since this Hill cipher is not being used anymore in this modern cryptography. Since right now we are using the public key cryptography, this Hill cipher is the symmetric key cryptography, which is the classical one. We no longer use that one. So mungkin which research can look into this matter to improve. Okay, is it okay?
Thank you so much, Dr. Lily. And I think that's all questions that we have. So, first of all, thank you for all of the audience active involvement and intelligent questions. And unfortunately, our session has ended today. Please note that the chatbot will contain the attendance form after photographic session, so please remain. Right. Before we conclude, I would love to thank Dr. Lily for sharing your expertise and taking us through this informative discussion. Your insight has been essential and we value your contributions a lot. Thank you to all the attendees for your participation and excitement. This collaborative teaching session was greatly enhanced by your contribution. So as we conclude, I encourage you to keep studying and applying the ideas to your studies and careers. Now we'll have a photography session with our speaker. Please wait and open the camera now and face forward.